Hello friends, here in this video we will see what is the core of a section and I will represent it on a diagram. So the concept is for core of a section, and for core of a section here I am considering a figure in which we have a circular section which is having the diameter as capital D. Now, core of a section means it is a region within which if the load is placed, then there will be no tension in the section. That is, it will be a region or an area within which if we are placing the load, then there will be no tension in the section. And suppose this cross section which we are seeing of a circle, this is a column. So we need to find out where the load is to be placed on the column so that there is no tension in that column. Because if the tension is there, then the column will be removed from its foundation because of tensile stress. So here I will say that we know that for no tension condition, eccentricity E should be less than or equal to Z upon A. Now, for the circular section, I will say that let capital A is equal to area of cross section of circular section, and that area of cross section will be pi by 4 into capital D square. Next, zxx and zyy, I'll say that it be section modulus about x axis and y axis respectively. Now first I'll calculate zxx, that will be equal to ixx upon y. So therefore zxx will be, ixx is the moment of inertia for the circular section about its x axis. So it will be pi by 64 d raised to 4, and y is the distance of the extreme fiber from the x axis. This distance is capital D by 2. Either we can take it at the top or bottom, it will remain same. So capital D by 2. So therefore here this I have written, actually it is Ixx, the moment of inertia denoted by I. Zxx is the section modulus. So putting the values here, therefore Zxx will be equal to, here I have Ixx pi by 64 d raised to 4 divided by y. So if I write multiplication, this will become reciprocal. So 2 by d, it is divided by d by 2. So if I write multiplication, that is 2 by d. So here we have 2 and this 64 gets cancelled. Here we have d and this becomes d cube. So therefore zxx is pi by 32 d cube. Now after getting zxx value, I'll put zxx and area in this eccentricity which I have written, keeping this as the first equation. So now I'll put the values. So therefore put zxx and area in equation number 1. So we have eccentricity E with respect to x less than or equal to zxx upon area, and the values are zxx pi by 32 d cube divided by area pi by 4 d square. So therefore E suffix x is equal to, here I will write down less than equal to pi by 32 d cube. Instead of division, if I write multiplication, this will become reciprocal 4 upon pi, and here we will be having d square. So now after cancellation, pi and pi gets cancelled out, d square gets cancelled, here d square gets cancelled, so only d remains 4, and this becomes 8. So therefore eccentricity with respect to x, that will be less than or equal to d by 8. Next I will say that since for a circular section Ixx is equal to Iyy and even y is equal to same d by 2, so therefore eccentricity with respect to y will be equal to eccentricity with respect to x. So eccentricity with respect to y is less than or equal to d by 8. Now after getting the values of eccentricities with respect to x, it is d by 8. So here with respect to x, I'll take a value of d by 8 on one side, d by 8 on other sides. This is E suffix x, eccentricity with respect to x. Next, eccentricity with respect to y axis, that is also the same value, so the same distance would be there. EY and EY. So after this, if I see, here we are getting an area. If I join all the points with the help of a circle, I am getting an area, and this area is nothing but, it is called as core of a section, and core of a section is that region within which if we are placing the load, then there will be no tension in the condition in the section. If the load is placed anywhere away from this black shaded region, then there will definitely be tension in the section, and then the column would be failing. So in this video we have seen what is meant by core of a section.